What's up, guys? And I hope you're good. So today we'll be doing algebra, which is question one in paper one. So what made me have interest in this particular question is the 1.3. Actually, on all the algebra questions, on all the question one questions, right? I'm mostly interested in the 1.3s because it's where we see if you really understand algebra or what. So let's get started. So 1.1, right? So 1.1.1 says we solve for x. So my equation is x squared minus 3x plus 2 equals to 0. So we're just gonna factorize x, right? It's gonna be 2, 1 minus minus equals to 0. Therefore x is equals to 1 or x is equals to 2. So like that's a 3 marks that everybody should be able to get, I think. So 1.1.2 goes as 3x squared is equals to negative 2 minus 6x. So, and it also says round off to 2 decimal digits. So the moment they say round off to 2 decimal digits, you obviously know that you're going to use the what? You're going to use the quadratic formula. So let's put this in standard form. So this is going to be 3x squared. So it's advisable to take everything to the side of the 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 the, the exponent, to the side of the squared actually, because it makes things much easier. So this is going to be plus 6x minus plus 2, I mean, it's equal to 0, right? So let's try to factorize this. Oh, I forgot, we're going to use the quadratic formula, right? So the quadratic formula is x is equals to minus b plus minus the root of b squared minus 4ac over 2a, right? So I'm just going to continue. Let me draw something. I'm just going to continue somewhere over here. So continuing this, we now substitute x is equals to, like, so it's advisable for you to write down what b is. So my a is equals to 3, right? My b is equals to 6, and my c equals to 2, right? So x is equals to what? B, which is minus 6 plus minus the root of 6 or squared minus 4ac, which is 2 all over 2a, and then my a is 3, right? So if you plug this onto a calculator, you should get negative 0.42. Remember, they said round off to 2 decimal digits, right? That's for the plus. And then for the minus, you should get negative 1.58. So that's the answer for question 1.1.2, right? So as we continue, the next question 1.1.3 says 1.1.3 says 2x minus 1 is equal to root 1 minus x. So obviously these are surds, right? So with surds, the first thing that we want to do, right, is try and remove this root, right? So the way we can remove that root, we can just square everything. So it's going to be 2x minus 1 all squared is equals to what? 1 minus x, right? So we're just going to expand that. And another thing, people think expanding, like this, it's dumb of you. It's not dumb of you, it's actually reassuring yourself that you're doing the correct thing rather than just telling yourself that I know this by head. So I prefer that you do this even if it's the long way, but then it's much more reassuring. So this is gonna be 4x squared minus 4x plus 1, right? It's equal to 1 minus x, right? So obviously we can see that this one is going to cancel that one. So, and then we're going to take this x to the other side. So we're going to have 4x squared minus, this is going to go to the other side, minus 3x is equals to 0, right? And then we're going to factorize this by taking out a common factor, which is going to be 4, which is going to be x, and then into 4x minus 3 is equal to 0. So x is equals to 0, or x is equals to what? 3 over 4, right? But then because we are dealing with SATs, right, we now have to go test whether these answers that we got, right, really apply to my equation, right? So if you test 0, right, if you substitute 0 wherever you see x, right, you're gonna get on the left hand side when substituting 0, right, you're obviously gonna get negative 1, right? And then on the right hand side when substituting 0, you're gonna get 1. So we can see that the left hand side is not equal to the right hand side when we are substituting what? 0. So we can say 0 is not a solution. So we say x is not equal to what? To 0. And then when we test 3 over 4, if you substitute 3 over 4 on the left hand side, I mean, right? So on the left hand side, you're supposed to get 1 over 2 if you substitute 3 over 4 into x. So it's going to be 2 multiplied by 3 over 4 minus 1, which is 1 over 2. So on the right hand side, if you say root of 1 minus 3 over 4, you're also going to get what? 1 over 4, right? 1 over 2, I mean. So 3 over 4 is applicable to my SAT. So my answer is going to be x is equals to 3 over 4. So the trick is with SATs, after getting your x values, you do not forget to test whether my x values are applicable to my SAT or what, or else you're going to lose 1 mark for not cancelling out one x value. Sometimes it's not always the case that they're always going to cancel out. There are going to be cases where they both are applicable, but then it's very rare, very, very rare. So question 1.1.4, right? I'll do it this side. So question 1.1.4, it's a quadratic inequality. So we have x plus 3 into 3 minus x is less than 0. So with a quadratic inequality, we know the first thing that we need to do is to try and find our critical values, right? So my critical value in this case, it's what? My first critical value is x is equal to what? To negative 3. And my other critical value is, or x is equal to 3, right? So I found my critical values, right? So there are multiple ways in which you can do this, but then the way which I prefer is using the parabola, drawing the parabola, even if it's not up to scale, but then just draw the parabola and look at what the condition that they're looking for. So the first thing that I have to determine, right, I already have my x-intercept, which is negative 3 and what? And 3. So negative 3 is somewhere here, and 3 is somewhere here, right? So looking at this, I can see that my parabola, it's gonna be a set face because my a is gonna be negative. We know that when a is negative, is less than 0, right, my parabola has a sad face, but then when A is positive, my parabola has a happy face. So in this case, my parabola is gonna go something like, it's not the best of parabolas, but then you can see what I'm trying to show you, right? So there's -3, this is 3, right? So we go back and look. So we are looking for where my x values are below. We are looking for where, we are looking for where my y values are negative, right? And we know that this is the y-axis, this is the x-axis. And we know that from here going upwards, all my y values are positive. From here, right, going downwards, all my y values are negative. So we want this part going downwards. That's the part that we want. So if you look at this, I'm just going to use a different color. If you look at this part, we can all see that it's above the x-axis, and we are not looking for the part that's above the x-axis, but we are looking for the part that's below. But when we look at this part, we can see it's below the x-axis. When we look at this part, we can see it's below the x-axis. So my answer should be from here exclusive. We do not include this part because at 3, right, my parabola is equal to 0. At -3, my parabola is equal to 0. So my solution should be something excluding 3, but then up to what? Positive infinity. My solution should be something excluding -3, but then up to what? Negative infinity, right? So my answers for this one, I'm just gonna say x should be greater than what? 3, or x should be less than -3. Okay, other people prefer to write it in another notation. Other people can say x is an element of, and then because it's not inclusive, you say from negative infinity up to -3, exclusive union sign from 3 up to positive infinity. You can also write it this way. This is not a square bracket, it's a curly bracket. The reason we do not include negative infinity or positive infinity is because those are not numbers, they're just like representations of how large our x value is. They are not numbers, so we cannot include them. You understand? So that's that for question 1.1. So, and then we'll be moving to the simultaneous, which is 1.2. Let me just clear up space. So 1.2 says solve for x and y simultaneously. So this is also one of the questions that should already be engraved inside you, and this is where you pick up marks, guys. So simultaneous are quite easy. The trick is just to try and avoid fractions, actually, because the moment you try and work with fractions, that's where you try and complicate your life, because most students cannot work with fractions. So I've got two equations, which is 2x is equals to y plus 2, and y minus 2 is equals to x squared minus 3x, right? So what I'm gonna do, right, I'm gonna try and say this is equation 1, this is equation 2. So what I'm gonna do, I'm gonna try and create equation 3, but then I can create equation 3 using equation 1, right, because it's gonna be much more easier. So my equation 3, I'm just gonna say y is equals to 2x minus 2. That's gonna be equation 1, 3, right? So my next step, I'm just gonna be using the substitution method because it's much easier for me that way. But then others also prefer the subtraction method, right? So what I'm gonna do, I'm gonna say I have to substitute equation 3 into equation 2. I cannot substitute equation 3 into equation 2 into equation 1, I mean, because equation 3 is derived from equation 1, is derived from equation 1. So I have to substitute my equation 3 into what? Into equation 2 and not 1. So that's where most students mess up, because as long as I have derived my equation 3 from equation 1, I cannot come and take equation 3 and substitute it back into equation 1. That means I have to go substitute it into another equation. So be careful of that. So right now, where I see y, I'm going to substitute what? 2x minus 2 into what? Equation 2. So it's going to be 2x minus 2. And it's always a good habit to parenthesize when substituting. And then I'm going to have x squared minus 3x, right? And then this side, I'm going to have 2x minus 4 is equals to x squared minus 3x. Then we're just going to take everything to one side. It's going to be x squared minus 5x minus 4, if I'm not mistaken. No, it's not minus 4, it's plus 4. It's plus 4. You know, another dangerous thing is also neglecting signs, because where we lose marks, it's also on signs. So we also have to pay attention on signs. So it's plus 4, not minus 4. So let's continue. So we're just going to try and factorize this. So we're going to say 0 is equals to x, it's going to be 4, 1, minus, so right now you should be able to factorize. I don't think that's something that should be on your worry list right now, right? So x is equals to 1 or x is equals to 4. So I've got my x value, so I need to go determine y when x is equals to 1, my y is equals to what? So I take equation what? I take equation 3. So when x is equals to 1, my y is equals to... The reason I take equation 3 is because equation 3 is already straightforward. It's already easy for me because y is already the subject of the formula, if you can see equation 3. So that's why I take equation 3. But then you don't have to take equation 3 if you don't want. You can take equation 1, you can take equation 2. At the end of the day, we're still going to arrive at the same answer. So we're just going to say y is equals to 2 into 1 minus 2, right? So y is equals to 0. And then when x is equals to 4, y equals to 2 into 4 minus 2. So this is just going to be 8 minus 2, which is 6. Then that's your simultaneous, and then you have your 6 marks in the bag. And then let's